Hello all, welcome to the episode 33 hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. Today we continue with Android platform and Java. This episode is about a few memory analysis patterns modeled as Android apps and diagnosed via state dump trace analysis pattern. We also learn how to differentiate between patterns in case of insufficient information, and we do that by using Android Debug Bridge, ADB, and associated Paratext memory analysis pattern. We model the spiking thread as a loop doing some math. So here is the code. On button click, we create a thread that in a loop does some calculations. Here, for example, it just chooses random number. Just 1 second, I have to take a cable for Android device. So okay, I have a cable now. So what we do, now I connect the real device. Of course you don't see that. I don't use emulator, otherwise it would take too much resources, and at the same time doing presentation. You see now log cut output starts. So I run now this application. It's already on device. So what it does, it periodically saves stack trace collection, the one we introduced in the previous episode. You see in green the output now, and this is the source code that is the same as from the previous session. So basically this is the previous log file. So this additional thread, so when we push the button, this thread is created. It is thread number 11, and you see it was caught doing getting the next random number. So it's not waiting, it's not the main thread. So let me now, I post the log file on debugging.tv later on, but let me now kill that application in Task Manager, the real device, and disconnect. So you see now we have that device disconnected message. Our next application models a deadlock. We model a deadlock as two threads having synchronized objects with different order of access. If you program in Java, you should be familiar with synchronized keyword, and you can use any object here. These objects are strings. So, and the order of access is different, and with the right sleep we get a deadlock. And if we execute this application, and again, so let's see, this is another source code. So here is the source code. So we create one thread that has CS1 and then CS2, the order, and then the second thread does in a different order, CS2 and then CS1. So when we push the button, these two threads are created, and in a state dump we would see thread 11 blocked in this source code line, and also thread 12. But when we look at stack trace collection here, we notice that we can't differentiate these threads from a spiking thread, because we don't see any waiting calls like we usually see in native stack traces, such as in Windows or in Mac OS X. Unless we call some waiting Java API function or factor out waiting logic into some separate function method. So unless we do that, it's very difficult to differentiate with this from, for example, the spiking thread. So the way to differentiate between a blocking call and a spiking call here is to look at external supporting information collected from other tools supplied by operating system. This is an essence of Paratext pattern, and it was initially introduced for Mac OS X memory core dump analysis. And to collect such information, external information about running application, we need to run a so-called Android Debug Bridge, ADB. And so what I'm going to do that, so I connect the device again. So you see login started. You see all this activity in logcard. Basically, this debug bridge is located in Android SDK in platform tools folder now. And the command is adb, and we run shell. So you see now, you see that Linux shell prompt now. And for example, the top command shows periodically, it shows all processes. And let me, for example, run spiking up. So I already did that. So I use Control S to pause. So if we look at the output, we see that spiking thread, I highlighted in yellow, example.spiking_thread. And now let me resume the output. And now I push the button. And now this thread starts spiking. So let me pause the output, and now we see that this spiking thread now consumes 96% of CPU. So let me now resume the output, and then let me quit the top. Let me run shell again. And there's also a way to see threads as well. For this we can use command ps to dump processes with T. So this command dumps not only one process, but also all threads. You see, this is up 57. This is our spiking thread, and here we have also thread IDs and thread names, and you see that thread 11 is running. You see that R, the last created thread. And for example, if I at the same time, if I run another app, Deadlock, and push the button, so two threads are created, and we should wait a few seconds. And let's dump processes and threads. So here we see another application, home example Deadlock, and all threads, for example thread 12 and thread 11, these are non-running threads, because you see they are marked with S letter. I put on these logs on debugging.tv also. So let's now disconnect the device. So all this you see on the slide as well. And what we call as paratext. This is what we see, the additional information that is not available in state dump. So this is all for this presentation. Now this is the usual add slide of forthcoming training sessions and free webinars. We added a new webinar on software diagnostics, requirements, architecture, design, implementation, and improvement, the so-called RADI process. But due to workload, the times of webinars are shifting. The next one will be about mobile software diagnostics. It should be next Tuesday, hopefully. And there is also a forthcoming accelerated Windows memory dump analysis training in November. next session due to requests. And so thank you for watching this episode. Please later check out the slides and recorded video from debugging.tv. And the next episode should be on the 16th of September, next week, next Monday, and we continue with Android. And we try to organize something about GDB session for Android. Okay, thank you very much for coming, to listening, and see you all next week. Thank you. Bye-bye.